Okay, this is section 4.3, continued, problem number 2. Notice I've got the same background. If doesn't make sense to you and you need to go back and you can look and listen to what I did for the first problem, but it's here in case we need it for reference. Number 2, the quadratic function here, and they want you to basically do everything. But you are not going to do it by transformations this time. You're just going to do this with the formulas that you were given to use. The negative b over 2a. Let's see, where is that? Right here. This negative b over 2a. This is what you're going to use. Be sure your quadratic is in the general form here. Everything is decreasing there. You want it in the form of the ax squared plus bx plus c. Identify your a value. Your a here is 1, so you realize it's going to turn upward. It's 1, that's greater than 0, that means it turns up. Now we're looking for the vertex. Even though it says x, it's really an h. We call the vertex hk, so I'm replacing that x with the h. Negative b over 2a. The b is 4, negative in front of it, so negative 4. 2, a was 1. 2 times 1 is 2. Negative 4 divided by 2 is negative 2. Then you would need to substitute in that negative 2 into the original function and find the k value, because it is the y or the function value. This is 4 minus 8 minus 5. 4 minus 8 is negative 4, minus 5 is negative 9, so the vertex here would be negative 2 and negative 9. If you felt like you had to put it in a calculator, you could go put it in the calculator and find out that it is negative 9. The axis of symmetry, remember, is a vertical line that cuts through the x in the vertex. So it's x equals negative 2. The y-intercept here would be negative 5 because it's like you plug in 0 for x. That goes away, that goes away. The only thing left is the negative 5. So 0, negative 5 is your y-intercept. Your x-intercepts are found by setting the function actually equal to 0. So we take the whole function, set it equal to 0, and you'll solve it. Whatever method you choose to solve, I always look for factoring first. Factors of x squared are x and x. Factors of 5 that have a difference of 4, 5 and 1, they need to have unlike signs, and the larger one needs to be positive. And if you foil that back together, first terms, outer negative x, inner positive x, gives you the 4x in the middle, and last terms, plus 5 minus 1, negative 5. Your x's then are negative 5 and 1. Those are your x-intercepts. Those are the points. You could have done this by completing the square. It wouldn't have been terribly difficult, or the quadratic formula. But factoring to me is the easiest. And of course, you can kind of check by using Desmos also. So I have checked everything with Desmos here before I proceeded further. And as you see, I put it in. My vertex is negative 2, 9. My y-intercept, 0, negative 5. X-intercepts at 1, 0, negative 5, 0. And I put in the line x equals negative 2 dotted there so you could see the axis of symmetry. That is kind of split between the two. Now you're supposed to graph it with MyMathLab. First, choose the correct tool. Then you will plot the vertex first. Then you will need to plot any of the other points. You can plot the y-intercept or one of your x-intercepts. You only have to plot the vertex and one more point is what you do. Then it says to determine the domain in the range. Well, for any quadratic, your domain's all real numbers, negative infinity to positive infinity. The range, notice the lowest y value was negative 9, and it goes up, so it goes to positive infinity. The negative 9 is included to positive infinity. A new question that they're sort of asking some now is the increasing and decreasing on the intervals. Where is it increasing and where is it decreasing? Where does the graph look like it's going up? Where does it start going up? Where did it start increasing? When x was -2. These are always given based on x. They're given left to right based on x. Right here is where the graph starts going up. You always have parentheses. You will not use brackets with increasing and decreasing. It was decreasing from actually negative infinity, and it stopped at that vertex of -2. So those are your increasing and decreasing intervals. I hope you understand this.